When the ground shakes, we go to find a shelter to hide or to run away. What we see is on the surface. But did you know what's happening deep down? The Earth's fault, which is underneath, move, causing the surface to shake.
What we're seeing, on the other hand, are the effects of the earthquake on the surface, with how our land moves from one place to another. But instead, it's called an erosion. But to be honest, I thought it was the same before I found out.
But if they were the same, we wouldn't be creating this video. My name is Quinn, your host for today.
And my name is Arvin, your co host.
Endogenic process, also known as tectonic process. It's called endogenic by the word endo means inside. There's actually two main processes, faulting and folding.
We both know there's more than two.
The endogenic processes usually take place on plate boundaries, which are not stable at all. Like faulting, rock layers can cause a fracture leading up to a displacement of a fault line due to the stress. Usually, they are a sign of weaknesses which causes molten rock to rise.
So, like, students?
There's three types: normal fault when it pulls back, reverse fault when it both collides, and then strike-slip fault that rubs one another side by side. But faulting, on the other hand, is it caused by comprehensive forces. Two types as well would be anticlines that are upward arching, while cyclines that are downward arching.
There's some subtypes as well, like volcanism or magmatism, when the magma beneath the crust is under pressure, causing magma to rise up due to faults and faults. Some of them don't ever come into contact with the crust though. There's intrusive, where magma is formed underneath, and extrusive, where magma is formed on the surface.
Reminds me of metamorphism as well. Basically, when heat and pressure are applied, it makes metamorphic rocks by the geologic structure.
Last are earthquakes or seismic activity. As explained by Gwen in the intro, it's basically when vibration happens in the crust, making Earth's plates move against one another, causing a built up strain to let out.
They can also be let out by the magma of a volcano before eruption.
I almost forgot.
About what?
The layers of the earth. We're talking about endogenous, yet we forgot to mention.
Well, let's have a quick summary then. Crust is the thinnest and outermost layer of the Earth, as seen with oceanic and continental crusts.
The second part is mantle, sandwiched between crust and core. It's semi-solid and gently flowing, mostly silicate. It's with two parts, upper and lower.
So, the core has two parts. First is the external core. It's mostly liquid and made of nickel and iron. And the fun fact is, it creates the magnetic field of the Earth.
Internal core is like the opposite twin of external core. It's solid but has the same materials. However, this time they're comparable to the sun's very own surface.
What? I didn't know that the Earth could be so hot inside. Which reminds me of our lesson about internal heat sources.
Now that we've gotten the layers out of our way, we can talk about another topic related to endogenic process.
To start off is primordial heat. When the Earth was being created, asteroids kept hitting one another, leaving some of their energy behind inside. Mostly, the energy is left behind by planetarians.
Another I know of is radioactive decay. It's when the energy is formed by radiation, when the atomic nucleus is unstable anyways. These mostly isotopes that are found in the crust, like potassium-40, uranium-238, and thorium-232.
The last one we know is gravitational convection. It's when the formation of stars, as a cloud of gases and dust, collapses under its own gravity. As the cloud contracts, the core temperature rises. Hydrogen plus helium will release energy, causing the star to achieve hydrostatic equilibrium.
That's when the accretion attracts forces, when small particles combine and form a larger bodies.
What's interesting is, there's three heat transfers as well: conduction, convection, and radiation. Conduction is when heat is direct contact between materials.
Convection is when movement of fluids or gas go up by a circulation pattern. Radiation is when occurs by electromagnetic waves.
Exogenic processes happen on the surface of the Earth, hence exo, meaning surface. It's like if all of the spheres had a baby, it will be this destructive baby. Erosion is a huge example of the exogenic process. Like I said, breaks down either by wind or water. The main cause, however, will be weathering.
The process in which the rocks break down or dissolve of rocks and minerals on the Earth's surface to smaller pieces. I heard that is usually because the water, ice, acids, salts, plants, animals, and temperature are affecting it.
Yes, that's correct. But actually, there's three of these types of weathering. First is physical weathering or mechanical weathering. This is due to external forces. Well, there's multiple types of this phenomenon. The next is frost wedging. That's when the water goes inside the rock and freezes it, causing it to crack. The last is salt crystal growth. It occurs when groundwater moves into the empty space of the rock. When water evaporates, the salt crystal grows, causing the rock to break under pressure.
Another example of abrasion is when the moving materials breaks into small rock. Biological activity as well is when the movements of animals and plants.
Well, that's correct. But another major one we know of is chemical weathering. It is when the chemical reactions change the molecular structure of rocks and soil. Usually, clay is the byproduct of these.
Biological weathering. Though it's the same as biological activity, it surely is in its own category. Plants, animals, and humans can intentionally cause weathering by their movements.